Good morning, students. Today we are going to see the topic future engineering. So it's actually come from Unit 2. Okay. So, future engineering is actually a machine learning technique that leverages data to create new variables that are not in the training set. So suppose we have data hidden or hidden in training set. So we are trying to leverage data by creating new variables. Okay, that is, it can produce new features for both supervised and unsupervised learning. So that the main goal here is to simplify and speeding up the data transformation with more accuracy. So that is the real purpose of future engineering. So let's see elaborately what's present inside this future engineering. So this session is dealing with future engineering overview, common approaches to futurizing with text, future selection, iterating and improving. That is, and dealing with mistakes. Okay, so let's start with the goals of future engineering. So first of all, we need to convert context into this input to a learning algorithm. Expose the structure of the concept to the learning algorithm. Work well with the structure of the model the algorithm will create. Balance number of features, complexity of concept, complexity of model, amount of data. So let us see one example here. 6 chances to win cash from 100 to 20,000 pounds. Text greater than C-11 and sent to 87575. Cost 150 per day, 6 days, 16 plus terms and condition apply. Reply HL for information. So this is actually SMS, right? As a spam SMS. So how exactly we are going to identify it's a spam message or not? So that is what we are going to discuss here. So if a SMS message it contains it's greater than 5-dimensional array of binary features. See, let us see one. If message is longer than 40 characters, means we will convert it into a binary feature. So if it is more than longer than 40 characters, we can put 1, otherwise 0. If a message contain a digit, then we will categorize as 1, otherwise 0. If a message contain a word call, then 1, otherwise 0. If a message contain word to, 1, otherwise 0. If a message contain word your, 1, otherwise 0. So like this, we will categorize. Okay. Now, basic feature text. So first of all, we have to always, when we convert it into a binary, we need to think about the length of the message. That's what if 40 character and above, then it would be 1, otherwise we have something like that. Then contains certain hash messages. We need to send SMS with the hash code, right? So automatically we have to check whether hash code is there. Contain punctuation, contain word call or SMS, something like that we can identify. Then categorical features means first word may be a verb, noun or other. Then message length we can categorize as it's a long message, very long message, short message, very short message, medium message, something like that. Then token type, whether it is a number, URL or a word, phone number, something like that. Grammar analysis, we can fragmentation, simple sentence or complex sentence. Then numerical features, count of words. Then message level, first number in message, right? Grade level, AA plus something like that. So these are the different categories we have to think when we analyze the text data. Then numeric features, usually we will convert this into a binary feature that is either 0 or 1. So I told, right, 40 above characters means 1, otherwise 0. Then numeric categorical features, we can have it as medium, large, small, something like that. Then again, categorical feature, we can have it as a binary one, true or false, 0 or 1, something like that. Or even this categorical feature further converted into 0 or 1. Either take short or medium and long. Long is 1, otherwise 0, something like that. Okay, so then binary feature as usual, 0 or 1. So this is the way we are converting. So that is like the pre-processing, we are converting the message. And then source of data for futures, we have to always check with the help of sensors. We need to see roaming of data. App in foreground, any app is running. Then content analysis, stuff we have been talking about, stuff we are going to talk about next. Then industry, demographics, all details we have to take care of it. Metadata, run the models on the content, grammar, language, properties of the sender, timing, phone number, all these features we can consider. And future engineering for text, these are the basic rules we we have to follow. So tokenizing, so tokens are smallest indivisible unit, right? Then we have TF-IDF. So TF-IDF means nothing but it is actually term frequency inverse document frequency. We'll see later elaborately about these things later. It is nothing but term frequency inverse document frequency. Actually, it is mainly used for information retrieval. Okay, to represent how important a specific word is there or phrase in a document. Then back of word, then embedding and n-grams in the sense natural language processing. N-grams, it's a unigram or it's a n contiguous sequence of n bytes. That's what we are calling it as n-gram. We will see these steps later. In NLP, natural language processing, tokenizing smallest indivisible units. We can't further subdivide. And punctuation, all special characters we have to build, then normalizing numbers, everything we have to decide and we have to decode. Okay, just go through the slides, you can understand. Then backup words, it's a collection of words that we can fall into the same category that we can take it as a backup words. So word of text is tokens and features. So that is just we'll group it and a similar word or scenario. So that is what coming in the backup words. Then n-grams, I already told, it's all about sequence of n-bytes extracted from text or for language processing and analysis. Uh, now, I don't think he goes to SF text FA to receive entry. So these things we will just categorize down the bank with from the bank. Say example and use when you have a lot of data, use many features. Then character ways we can decide, help without dictionary words and spelling errors, fixed number of features for given and then which features to use, how many features to use, these are all we need to decide for the feature selection. Then only we can able to done well with feature engineering. Okay, and we have to consider this mutual information, accuracy and frequency also. Then take top in most common features in the training set, and based on that we can check the frequency. Then definitely we need to understand the mistakes, odd man out. We have to remove those things, the noise in the data like encoding, bugs, missing value, corruption, everything we need to remove clearly when we are doing the pre-processing. Noise in the label, as per your request, melle melle, ஒரு மின்னா மினிக்கின்றி நொறுங்கு வெட்டம். Actually, it's Malayalam tab, has been set as your caller tune for all callers. Press asterisk 9 to copy your friend's caller tune. So it's spam. I will meet you at the restaurant between 10 and 10:30. Can't wait. So like this, we can categorize and we can identify whether it's a spam or not spam message. These okay. So these are all possible. Then label noise, slang, non-English words are there. So we can avoid. We can identify the mistakes. Okay. So, as I said earlier, when we approach to feature engineering, we have to establish standard for a domain, one parameter per 10 samples, try all the important variations on holdout data, tokenizing backup words, n-grams, etc. Use some form of feature selection to find the best, evaluate it, look at your mistakes, use your intuition about your domain and adopt standard approaches, or invent new features, iterate. Okay, then you want to know how well you did, you have to explore. Future engineering in other domains also there, computer vision, time series, neural networks, even internet. In basically we can say that by summarizing, raw context into input for machine learning, we make match structure as concept to structure of model representation, balance number of features, amount of data, complexity of concept and power of model. So every domain has a library of proven feature engineering approaches. Text include normalization, tokenizing, n-grams, time frequency, IDF embedded, embeddings, and ML. So future selection remove less issues.